So basically, almost all the topics we have covered so far. So the only topic left is the tools one. So basically, what we are going to look here is majorly what and all tools will be there. So for each and every activity, there might be different tools actually. So all these tools we will be seeing it today. So first we will be looking at the V model basics actually. So on which basis the software development will be happening is what we will be looking today majorly. So in each and every process area, what and all tools it is required. So Polarian for the requirement analysis, as yesterday we saw it, right? So then enterprise architect, then Notepad, on Notepad frequently we are seeing it for the software editing and all we will be using it, and vector cast. So vector cast I'm not sure whether I will cover it today or not. If not today, I will give you the recorded video for that. Okay. Then Jira, Trace 32 and Canoe together I need to show. If time permits, definitely we will be seeing it today. Okay. So apart from vector cast, almost everything we are going to see it today. So let's start with the V modeling. So let me take one of the readily available diagram for that. So basically this is the V model diagram. So what basically depends on this model only we will be doing the entire development process actually. So this entire area they call it as a system engineering group, SIS, and software engineering process groups, SWE they call it as SWE, and supporting process groups and all that you don't worry. Man process also you don't worry. Process improvement, supply process group, acquisition process, this and all we no need to bother about. Okay, these things. So what we are going to concentrate mainly is into the software engineering process area, which will covers both the um, testing and the development part, most of the things. And the testing part it will covers a little bit right side of the V also. So this basically we call it as a V model, this symbol. So you can see all the process areas will be coming on the development phases will be in the left side, and all the testing phases will be on the right side. Okay. Requirement elicitation, system requirement analysis, system architectural design, system software requirement analysis, software architectural design, software detail design, and unit construction, unit verification, integration and integration test, software qualification test, system integration and integration test, system qualification test. So these are the process areas which we will be hearing in the entire automotive development phases actually. So you don't worry about the all the sides and all. So the red highlighted one is there, right? This is the box which we need to understand. In this also you no need to worry about the system level. So mainly concentrate on the software part and the testing part. Okay. This system part also we no need to bother about. Okay. So what it is meaning to say, you might be knowing that SDLC, right? Software Development Life Cycle. You might have studied in your bachelor's. Okay. So this what and all it will says that requirement analysis, then design, then coding, then testing. I think so. These are the main topics which it will be covering. So here also you can see, so it's a top-down approach actually. So requirement and elicitation. So requirement elicitation will be happening at the two levels, one at the system level, one at the software level. The system level, what it will be doing, the requirement analysis in the sense, they need to think about the software, they need to think about the hardware, they need to think about the mechanical as well, as it is system for the automotive. Hardware in the sense it will covers both electrical hardware and electronic hardware, both the things will be covering here. So they need to analyze about what kind of hardware mechanism they need to follow, what kind of mechanical parts they need to follow apart from the software. Okay, for these electrical and mechanical guys, there will be a separate process areas, but that we are not going to discuss here. Our main area of discussion today is software development process along with the testing. Okay, any doubts? So this is how the system requirement elicitation will be happening. A requirement elicitation and the requirement analysis. These two phases they will be doing the analysis of software, hardware, and mechanical requirement. Elicitation, I can say that. So for example, if you want to develop any of the ADAS issue, for example, if you take, okay, for this ADAS issue, what and all features they wanted to support, whether ACC needs to be supported and AAB has to be supported and TSR has to be supported. This kind of high level elicitation it will be done here to support these particular features. So what kind of software requirements they need to have it, what kind of hardware they need to have it, what kind of mechanical parts they need to have it. So in case of hardware, again, what kind of microcontroller it is needed. If it is a microcontroller, how many bits of microcontroller, 16 or 32 bit. If 32 bit, how many CAN channels it has to support, how many Ethernet channels it has to support. So how many ADC channels it should be having, how much memory it should consume. So all these analysis they will be doing the requirement analysis. Okay, then the system requirement analysis it will be debugging little bit more. So this is a microcontroller which is so and so family. It should be 32-bit microcontroller and memory should be 16 MB should be there. And this is for the hardware level. Mechanical level they will be deciding that what kind of material should be used for the to maintain that particular issue, whether that is aluminum or mixing of any other mechanical lubricants to be not lubricants exactly, what kind of how can I say this, aluminum, nickel, and these combinations will be there for exactly with them. So what kind of material they have to use, why that kind of material they will be choosing is, if you are keeping your ECU in the vehicle, even if it is 100 degrees to 150 degrees, or minus, sorry, I can say minus 40 to 150 degrees, the ECU should not be get corrupted. There should not be any corrosion effects in the future also, even though if water is pouring on the particular ECU. So by considering all those environmental conditions, even if you are keeping the salt, it should not be affected. So by keeping all those conditions, they will be coming up with the mechanical requirements. Okay. So all those things it will be coming, and in the system level, they will be having the diagram where they will be how this particular ADAS ECU is going to interact. That is at the vehicular level, but inside the ADAS ECU itself, if multiple microcontrollers are there, how they are going to interact and all those things, how the communication will happen. What will be the baud rate of CAN communication if what and all CAN communication is there. So this kind of requirements it will come. Okay. Okay, so yeah, and then it is coming to the software requirements. Yesterday we have saw it, right? All those guys are the software requirements. Then for that software requirements, we will be doing the design. Okay, so that design basically, let me tell you the tools as well at the same time. Okay, it's okay, fine. I will be telling first these things, then I will be explaining the tools for each and every process area. Okay. So that design, how what and all designs it will be there, this will be doing with the enterprise architect tool actually. So high level design and then low level design or detail level design we call them. Okay. So in this detail level design, the activity charts, sequence diagrams, all these things will be there actually. Okay. Then software architectural design and the software detail design, almost it will be coming same. Architectural design and software detail design, and then these two things we will be doing with the same tool that I will be telling later. So next is the unit construction that already we have seen it yesterday, like how we will be doing the unit constructions and all with the both you might be, if it is a DaVinci and you will be doing the BSW configuration, then DaVinci tools we will be using it, and it is just logic implementation at the application layer, then you will be using the Notepad, something like that, as editing tool. Okay. And software unit verification. So what software unit verification is that, guys, this all those things you no need to, you cannot be remember all those things at a time, but you can just search in the online that ASpice. Okay. ASpice V model, then you will get each and every process area what we will be doing that. This you might have studied V model in the our bachelor's itself, but this ASpice is the, how I can say is like, it is particularly made this V model only for the automotive. Okay. So this software unit verification, what we will be doing, so yesterday we have seen, right, TSR is the one software component. If we are developing this one, any of the piece of code, only for this level, we will be doing the testing actually. This is unit verification. Okay. So only this particular feature we will be supporting. We don't bother about what is the inputs and outputs. So we will be bypassing. In our case, basically we have seen it yesterday, right? So majority of the inputs will be coming from the IQ. So that IQ inputs itself we will be disconnecting, then we will be testing them. Only purely software testing. There will not be any hardware depending on this unit level testing. This is Vectorcast is the tool which we will be using. Okay. For this, I have the separate video that I will be giving you. Okay. This is having almost 1.5 hour video actually that I will be giving it. Okay. So next, software integration, software qualification, system integration, system qualification, all these things will be involved with the ECU. ECU you will be connecting. Okay. Then this ECU, on this ECU you will be flashing the software, then you will be testing it. Okay. So what is the, so you are saying that you might be getting doubt that you are saying all these test areas will be getting connected with the issue and then testing. What is the difference in the each and every level of testing is what your question might be. Okay. So in this software integration, okay, so there will be a couple of developers who will be doing their individual development activities. So all those developments we will be integrating it. On top of that, there will be some chances that so in our case TSR and AAB are there, right? So if these two software components are connecting with each other, so if I'm sending data from AAB to TSR, whether it is able to transfer properly or not. In case like from TSR to AAB, if any of the data is coming, whether it is properly transmitting or not. So that kind of integration we will be checking. Like once we are integrating all the software components, whether the software is working properly or not, that basic testing we will be doing from the software team. These three things majorly it's depends again. Okay, software qualification, software unit testing, software integration testing will be done by the software engineers basically, but in very rare cases for software unit verification also there will be a separate team. For integration and integration test also there will be a separate team. For software qualification test also there will be a separate team. Okay, and system qualification and system integration testing will be done by the system V&V team, we call them, verification and validation team. Okay, they will be doing the they will be doing the testing on the basis of system requirements. So not requirement analysis, system requirement analysis will be system qualification test will be happening in parallel with the system requirement analysis. System architectural design, to that parallel the system integration and integration testing will be happening. Getting it? Any confusion? Similar way here also, to the parallel of software requirement analysis, software qualification test will happen. So this software qualification test will be done against the software requirements. Okay, software integration and integration test will happen on against a software architecture. Software unit verification will happen again as software detailed design. Getting it? Once again, I copy pasted the same diagram. Guys, getting it? Huh? Any doubts here?
Yeah, getting.
Fine. So this requirement elicitation is there, right? So this is at the OEM level, we will be getting the requirements, right? So for these requirements, there will be a vehicle level testing. Vehicle level testing. Okay, so this particular issue will be placed in the vehicle, then vehicle will go on to the real-time run, then it will be tested on the vehicle itself. Okay, so there will be a lot of testing will be happening at the different levels. Okay, here again we will be having hill hardware in loop, we call this as, and then this we call it as a SIL, software in loop. So these two things will come when if you are doing the model based design and coding. Getting it? Any doubts here? So now we'll see what and all tools we will be using at each and every level. Okay. So we saw it, and also before that, I wanted to tell you one more thing. Okay. So requirement elicitation to the requirements, there should be a linking. Software system requirements to system architectural design, there should be a link. System requirements to software requirements, there should be a link. Software requirements to software architectural design, there should be a link. Software requirements to software unit construction and design, there should be a link. Okay, from detailed design to unit verification, there should be a link. From software architectural design elements to the software integration test, there should be a link. Software requirements to software qualification test and the results, there should be a link. System architectural, system integration, system requirements, system qualification test, OEM requirements to vehicle level testing, there should be a linking. So this is what we call it as a bidirectional traceability. Bidirectional traceability. Okay, so from system qualification test, if you are referring any one of the test case, then you should know that for which requirement we have written the test case. Okay, so that is what it will be bidirectional. If you are seeing any of the requirement at system level, on which basis of customer request we have created, there should be a bidirectional. From system requirements, if you are seeing any of the software requirements, on which basis you have derived this software requirement, there should be a direction. I mean the linking. Okay, from software requirements to the software detailed design and the unit construction, there should be a linking. Okay, In the similar way, in all cases, there should be a linking. Okay. So if you are clicking from here, then you should go to the software requirements. That kind of traceability there, and there must be. Getting it? Huh. So, so in this case, what will happen? So this entire things we have seen it yesterday. The requirements and all those things will be there in the Polarian. Okay. So the similar kind of tools, we do have a lot of other tools actually. So where we will be having um, IBM ALM tools and IBM doors. So similar kind of tools will be there. So this requirement illustration, requirement analysis, design will not be there in the Polarian. Design, system architectural design, software architectural design, software detailed design will be there in the either in enterprise architect, enter, enterprise architect, price architect, or in the Rhapsody. Okay. So there are a lot of other tools actually that also we can use it. Okay. Then unit verification, as we discussed, vector cast is the one, or RTRT, or Google test, G-test we call it as. So all these kind of tools will be there. Okay. Now for software integration, software qualification, software integration, system qualification, all these things will be happening with all these things will be happening with. So for CAN simulation, we will be using the CANOE, and for debugger, as a debugger, we will be using the Lauterbach debugger, Lauterbach, or WinIDEA debuggers. WinIDEA. Okay, got it? Any doubts here? For unit construction, I mean for coding, basically we can use if it is a configurator, BSW configuration, then DaVinci, developer and configurator, and uh, normal editing notepad. ఇప్పుడేమే notepad and Eclipse. Then if it is a model based, then MATLAB. These kind of tools we will be using it for the unit construction. Okay, guys, did everyone got what is the tools? What kind of tools we will be going to use? So the similar thing we have noted also here. Can see it. So Polarian for the requirement based database, enterprise architect is for the software design, notepad for the software edit, vectorcast for the unit testing, Jira is for ticket tracking, trace32 is for software testing and debugging, canoe for the can message simulation. And also we are missing one more thing for the SCM. This is a configuration management, software configuration management. Okay, here basically I will be showing you the plastics. Okay, so similar kind of we will be having, you might have heard about the GitHub, and we will also have the ALM also here, and SVN. So all these similar kind of tools we can use it for the configuration management. Okay, so out of this I will be showing the in Polarian how the bidirectional traceability will be there. Okay, In enterprise architect, I don't think we have that much time for doing the enterprise architect design. But let's see. This enterprise architect design I will be taking in the last, okay? Or else I will show this instead of enterprise architect, I will show in the Rhapsody. Okay. And Jira, you might be knowing that. So for example, what is this Jira? You know, if you are doing one requirement, okay, one requirement development. So this requirement will be linked with this Jira tracking. This is basically the tracking tool, okay? What you are doing, what and all tickets it is been assigned to you. So when you are going to finish all of them, then that will be there in the that will be listed in the this particular Jira tool. So this Jira will be differ from different teams and different companies also. But you can just remember that this is one of the tracking tool. Okay, now so instead of guys, yesterday you have seen Polarian, right? In the similar way, I do have the ALM actually, which is from the IBM. So that tool, if I'm showing, that's fine for me. Why? Because you will be going to get to know that the Rhapsody linking also it will be happening there. Anyhow, Notepad I will be having that PC. Similar kind of Jira I also have it, and Trace 32 Canoe everything it will be there in that PC. Let me take that control of PC. Guys, just give me a minute. I need to log in that PC. I hope all of you are able to see my screen. Hello. Hello.
No, it's yes,
So I think you are able to see my screen. I think so.
yes.
So instead of taking, uh, so this is also the similar kind of the Polarian tool. Okay, that was from the Siemens. This is from the IBM. Okay, you can see here IBM Engineering Requirement Management, which is the doors. Doors next. Doors next is the ALM tool. Screen is visible to all of you. That is very small letters on the top actually. So this is also similar kind of tool. You can see that. So if you take the diagnostics itself, okay. So for each and every software requirement, this is basically which one is this? SysRS. SysRS in the sense system requirement specification. Okay. So these are the requirements basically from the system engineering. Okay. You can see all these are the diagnostics requirement what we were you guys were studying in the UDS protocol. All the DIDs and all the 22 service you might have heard it, and 27 service security access, and hard reset 1101 programming session 1002 how it has to be working, and general requirements for the diagnostics like physical and functional requesting, what is your testing tool address and all those things. Okay, so you can see each and everything is a bidirectional. So this particular requirement is telling that what is the status. This is accepted requirements, which means that software engineer is going to accept it and he is going to implement it. System requirements. So the system non-functional requirements in the sense this is just a information to the all the people, all the stakeholders I can say. Okay, implemented by you can see here. So implemented by what? Implemented by this particular Jira ticket number. This is the Jira ticket number. If I open this, you can see it is opening here. This is the Jira. Okay, inside it, it will be having one ticket for the software engineer as well. Software course specification. You don't worry about how these links and all are there. It's depends on the project. It will be differing for everyone. So unit implementation you can see. So here this will be having the this will be having all the details actually how much time you are going to take to implement that particular entire feature itself. Okay, and when is the due date and who is going to implement and what is the safety level, security level, all those things will be there. So if you are doing any modification on that ticket, you can give your comments. So I was doing something on this particular ticket, so I have given something. Okay, if you want to see if it is having any links and all in similar way, time tracking also you can see approvals if anything are there, and then for overview history you can see who and all done what and all changes, when they have done, on what date, what time. Okay, this is how the Jira ticket will be looking like for each and every topic. We for each and every task the manager will be going to create this Jira ticket. So this Jira ticket, so basically we are doing the development, right? So this is a development Jira ticket. Okay, for the testing guys, they will be having one ticket for the testing, and if in that testing if they are finding any of the bugs, yeah, I will show now. So on my name what and all bugs are there. So here all these things are the bugs only. So submitted it is there, right? System supplier boot control software version is not working. So you can see here it is a defect. Who has created, V&V team has created it. So I test results is I have not yet fixed this software bug, so still it is in open only. Earlier Praveen, who is from the testing team, that guy has tested this particular feature. So and then while creating the bug, he will be giving what and all scenarios he covered it, what is the test sequence he covered it, and what he is expecting, but exactly what he is getting it. And also he will be attaching the proof. So this is the proof he is attaching to say that he has tested that particular use cases. You can see here. He attached from the can log. Getting it? Any doubts in Jira? So either development ticket or defect ticket will be there for testing. Either testing ticket or the defect tickets there will be a there only in the Jira. Okay, fine, right? So this is how the system requirements will be there. So here also you can see that it will be linked with one of the system software requirement also. So satisfies is there right on top. You can see this satisfies what it will be linking to the software requirements. So if I'm clicking on this one, it will go to this SRS, which is a software requirement specification. It is opening here. You can see. So this is the requirement which it is linked for the. So this is a basically system requirement. Sorry, software requirement which you are deriving on based on the particular so and so system requirement. So this is a system requirement which you are having it. So on that basis you are deriving the software requirement here. Getting it? So let me open the SRS directly now instead of coming from the um, those guys from the system engineering requirements. Let me directly open the SRS. So this is basically SRS. You can see SRS pakar underscore CSG. This is the document name which we have given inside the our this one inside our tool, ALM tool. This ALM also it's a similar kind of Polarian only. Almost I can say 90% it is same, but the vendors are different. That's all. For Polarian it is from the Siemens. For but ALM is from the IBM. Getting it? Any doubts? So here you can see each and every software requirements. I will be referring what is the artifact type, whether that is a software requirement or the just the information for the software development or any non-functional requirements, all such kind of things we will be giving it. Let me take one of the DID, then I will show you. F131. So let me take any one of the DID, which I will take F181 only. Okay. So F181. So this is a software ID number, or else I can take something else here, which you can take this one, vehicle manufacturer spare part number. Okay, for each and every ECO, the vehicle manufacturer who is the OEM, they will be giving one spare part number. Okay, this is the requirement. So for that requirement, what they are saying is this particular data I will be storing into the memory of ECU. Whenever the OEM or anyone else, if they wanted to get to know what is this particular ECU spare part number, they can able to read it with the 22 service. 22, if you are clicking F187, then they could able to read it. So this particular entire requirement we will be seeing it now. So starting from this software requirement elicitation to the software implementation, software unit testing, I will not be showing it. I doesn't have any tool for that. Anyhow, that I will be giving the video. And after that functional testing, we will be seeing it, which is a software qualification testing. Okay. That part we will be seeing it. Okay. So and also guys, just remember me, this quality check tools we forgot it, that we need to see it. Okay, that anyhow we will not be doing it, but you should know that what tools they will be using it. Just let me know in the last, okay, if I forgot. Okay, so this vehicle manufacturer spare part number F187. So from where we have derived it? So if you want to add any other artifacts also, like still you can add here. Child of active out format comments created and created by, embedded in embedders, extracted, implemented by, modified, primary referenced by, specified by, satisfies by architectural element, validated by. So all these things we will be seeing it. Okay, so you can see here. Sorry, it got closed. I will be reopening all of them once again. So inside functional requirements, this is also kind of Word document only. Okay, don't worry about all these things. But in the tool, we will be using it. Diagnostics. So inside services, we have 22 and 2E service here. So here you can see what was the DID number. Vehicle manufacturer spare part number. Okay, this F187. Okay, this F187, if you see in the system requirements also, it will be almost same. Okay, so there will not be any major difference from the system to the software requirements. So almost we will be doing the copy pasting. The system engineer will be giving almost the equal information which we needed it. Okay. Only I'm opening two ALM tabs. One is first one is the SysRS, second one is the SRS, which is a software requirement elicitation. Okay, so what if we are telling that this particular DID will be going to have the 15 bytes of information. Okay, what value should be there is what we will be specifying in the software. So what is the primary memory location is the application software, and backup in NVM is needed. Yes. Then sessions in application, what and all sessions it is going to support is in default and extended sessions it will be supporting. Only read service it will be supporting, which is a 22 service. In FBL, which is in bootloader, default programming extended sessions it will be supporting only read service. Okay, so for this, if you want to see like this is a software requirement and this is accepted by the software engineer, and the safety level is the QM, means quality management requirement. So basically guys, there will be some functional safety topic actually. If anyone is interested, please just go through that. Okay, I cannot elaborate on that one right now, but you can just go through that. It will be having ASIL A, B, C, D levels actually, which is ISO 26262. If anyone is interested, you can just go through that particular ISO document. Okay, and software verification criteria, verification level, software test will be done, and review whether software engineer has been done this review or not. If you are deriving this requirement from the system engineering, right, you need to do the review again. So if you are accepting, then it's well and good. Okay, and then where it is getting satisfied, it is satisfied whether this is a system requirement what it is showing. So that's what I was telling, bidirectional traceability. If you are linking if it is linking is done, if you are clicking from the software requirement, then you should be able to go back to your what is that system level requirement. So this kind of linking should be there, bidirectional linking. Okay, and tags, what and all tags it is having, we are just giving the tags like whether it is where it is going to implemented in the R1 release or R2 release. If this requirement is going for the review, then what is the review ID? Okay, guys, and one more thing, if you are deriving the requirements or if you are doing the design, if you are doing the software implementation, all those things will be having one review. Okay, this we call it as a smart BR review. Okay, so here we will be reviewing, we will be adding the reviewers. If you see any one of the things, so which I have created review for software specification, after deriving the software requirements, I have created this review and I added all the stakeholders whoever had to be review these requirements. So I have added all my teammates to review my requirements. So this is just review process. Okay, so similar way, who has created these requirements and all will be there, and implemented by. So this is the Jira ticket number, what you are seeing here. Okay. And verified by, these are the test cases. If you are doing any test cases development, that test cases also will be linked here. So if you are doing any design elements, that design elements will be linked here. Any doubts here? So if there is no doubts, then after software requirement analysis, then we will be doing the design. Let me show you the design. So this is a Rhapsody tool actually, which is installed. I'm directly opening it. I hope all of you are able to see Rhapsody.
Yes.
Yep. So in this tool, we will be doing the design actually. So designing in the sense basically, what we will be having, it's a basically under UDS, I have that particular design. In the design, basically we will be having flowcharts actually, behavioral views. If you see under this, you can see here somewhere the design for F187, right? What was that? Don't know. I have drawn the design or not. This is in which release? No? Maybe for that F187 particularly, I have not done the design. It looks like, but the design will be in the this way only. So basically, so if you see the other DID here in the requirements, okay, same other DID you can see which is there in the R3. Okay, so issue installation date. Okay, or else issue installation date itself you can take F190. So exactly when you are going to install this issue in the vehicle is what that date will be saying. Okay, F190. Okay, ECU installation date, which is a 4 bytes of data. So that must be there in the design. So here you can see F190 read data. Okay, just like what I'm trying to do, I am trying to just do the design like copy the data from RAM mirror memory to the data pointer. Similar way, if you take F1, sorry, similar way if you take any other DID, DID is a good option for all of you. I think you might be not able to see the design part, but I can give you the best suggestion is FD41. application software identification number. For each and every release, we will be giving the one application software identification number, FD41. FD41 you cannot see in the require this design, but that also it will be coming in the similar flowcharts. Okay, so here we will be having the some elements that we will be using it. So this initial flow is this one. So initial flow already has initial flow, so that's the reason it is not giving it. So this will be the initial flow, and then here inside that whatever the matter you wanted to write, you can write it. So again, if you want to have the action, you can use this one. If you want to have the decision node, you can use this one. And the final, once the activity chart, this activity chart will be done for each and every function. Okay, whatever the functions you will be doing inside your C language, for all of them you will be having one activity chart. Okay, so final will be once it is done with the final, then there will be a activity final. So this is how we will be connecting all of them. Control flow, we call them the arrows. Okay, inside that, however the matter, however the connections you wanted to have, all those things you can do it. Getting it? Any doubts here? And also you can see here, this particular element is linked for what? It is linking to one of the requirement. Okay, you can see the RBALM underscore this link, right? This is the requirement link, software requirement link. It will be linking with the F190 what we have seen here. The previously we have seen one of the DID, right? For that it will be linked. Sorry. Hello. Yep. So this is how the linking will be happening. Bidirectional traceability we call them. So for F19 FD41, which is application software number or any of the other DIDs, if you want to see, you can see here. So inside diagnostic application software component, we will be having the designing. So let me open in the notepad only. Yeah, as you guys are familiar with the notepad, I will be showing you in the notepad itself. So FD41, if I am clicking it, so for FD41, we will be having one of the function here. FD41 read. Okay, so what if you are reading FD41 from your tester tool, the control will come to here. So then what it will fetch is like it will fetch the whatever the information there in the application software version number parameter. It will be just copy into your data. This data it will be coming to your testing tool. That also we will be seeing it now. Okay, so you can see what the value will be there in this particular variable also. So for each and every software release, this particular variable we will be changing it actually. To find out any of the data, you can do the control F in the notepad. Okay, so here you can see this parameter is being defined with the default data. I don't want with the default data. Here you can see line number 103. So it is a 222801, which is year, week, and patch. Patch in the sense in that week itself, how many times you are releasing the software. 28th means this is today is the 28th week. You can see in the outlooks, you can get to know this left side ones are the weeks. Okay, 28th week of this year, this one 52 weeks will be there, right? So this is the 28th week of it. So the 22 is the year, 28th week. In that week we are doing the first release. Okay, so if you are reading FD41 from your diagnostic CANOE, then this value is what you will be going to get it. Got it? So for that requirement, this is how we will be doing the coding. Any doubts till here? So and after this, basically we need to do the unit level testing, but in our case, they will be done by the some other team actually. But I will be giving that video how they will be doing it with the vector cast is what you will get to know. Okay. Similar way, all the DIDs will be implemented. You can see.
One doubt, Lokesh.
Yeah.
Yeah. So, how much time it might take to get familiar with all these things?
Hey
Like,
guys, if you are doing once or twice now, then see, basically, no one will be expecting the tools knowledge here, okay, in automotive. But if you are doing once or twice this tools, then definitely will be get familiarized. These tools are not that much complicated. We're getting it. It's up to you. Like if you know the basic concepts of it, so that's the reason we are coming from very basic. So you guys might be knowing like from where we started it. We started from where like what is the embedded system, what is the real-time embedded system. From there we started and we are here right now. So you can compare yourself when we started our classes where we were and now today what is your understanding.
yeah. What about this C C? Because we learned like basic coding, but here like it will be more complicated or like that.
No, have you seen anywhere more complicated things? These all are the
Um,
code. These all are the tool generated one. Inside it, you have done this coding. Okay, what you are doing? This v standard library memcopy is the standard function, standard library function. What it is doing, the copy of from this parameter to this parameter, which is of size this much. Is this very complicated one? Memcopy function. If you see in the Google, also you will get to know. First will be the destination, next will be the source, the next will be the how much size of memory that is. Next, what you are doing, index equal to index plus 4. This value is a 4. Whether this is a complicated one. Next, what it is having, if loop, else loop. So this if else and all, how to apply, where to apply and all, you will get to know if you understand the requirement.
okay.
Any other things are there apart from if else loops?
No.
We already thought that whatever it is required at least for you to certain settle in this embedded field, all those basic concepts we have covered so far. You should not be get surprised or something should not be unknown if you are entering into the company. So almost all the basic concepts we have covered. This is the final class, I think so. For the tools, what kind of tools it will be there, so how it will be get utilized and all these things we are seeing it. I'm pretty sure that it will be bit difficult for all of you guys to follow all these things. So that's the reason we have the pre-recorded or recorded videos already. You can just go through once or twice once again. So then you will get to know what is this all about.
Yeah. Okay.
For me, it will be little bit easy. Why? Because I will be doing it. But for you, I know it is a difficult. But if you are seeing once or twice, it will become familiar for you also. If you are getting any other doubts that time, you can just go back to our team or you can ask any one of them. They are not able to, answer your questions, then just type your doubt in the Skype. If it is a very lengthy doubt, then I could take just a 5 or 10 minutes class for that doubt itself. That's no problem for me. Getting it? So all these things it looks like a complicated one, but it's not at all complicated. This entire file we will not be developing within a day or 2 days or 1 month or 1 year. Okay, it will take some years to develop the code.
Yeah. Okay.
So if you are doing this kind of 100 lines for 1 month, also it's a fine. We will be doing it. We will be testing it whether the expected result are coming or not. We will be checking. If not coming, again we will be analyzing the code. What is happening? We will be checking. So gunshot within a shot, no one will be can able to do the coding. Okay. So and it's also in some cases you will not be able to understand some of the concepts. Still, you can go back to Google and you can search it and how that concept will be working. You can understand it. You can implement in the real time also. That's also fine. Still today also, if I'm not able to understand any of the concepts, still I will refer the Google. Not only C language, whatever it will be. We have very good source where we will be getting a lot of information to understand the things. Okay, got it? Any difficulty? What we were seeing is the application software number. This is the ID which we will be getting if you are reading this particular application software version number from your Canoi tool with the 22 service. Any doubts here? If no doubts, then I think we saw it almost all the required tools. Now we need to compile this particular software. Okay. For compilation, so when we were doing the C language, right, we have seen the online compiler, right? In the similar way, for this project levels, we will be having the project specific compilers. Okay. So that is up to the team. So where they are keeping the compilers and all those things, you no need to worry about how this is there in this project. So in my case, we have the command prompt actually. So inside compiler, this is the one which I will be build is the one which I will be running for the compilation. So if I will be just clicking CMD from here, so I will be just running that batch files, build.batch file. I think we have seen it also in the initial class. Again, we will compile it. After this compilation, the executable hex file will be get generated. That hex file we will flash into the ECU, and how to flash and all you will get to know with the Lauterbach debugger. Okay. After that, then we will try to run it from the Canoi tool, and we'll see a couple of DIDs and some CAN messages transmission and all those things. Okay. Got it? So let me compile this. I have not expected this much time, but let's see if there is any changes. Mostly it will take 2 to 5 minutes actually for the compilation. Then finally it will generate the hex file which we can flash inside the ECU. So before flashing it, I will be explaining what kind of connections it will be there. Okay. So now it's a compilation is done. You can be seeing in the final that hex mode executed successfully. So it's depends on the project to project actually how this compilation will happen. It will not be same in each and every in each and every project. Let me show you the how the connection. So now the till compilation we saw it. Now next step is like we will be flashing this code into the software. So before that I wanted to show you the physical connections how it will be there. Guys, I'm sharing my screen here again. Before that, I wanted to tell you before flashing, I wanted to tell you how the hardware connections will be there. Okay. So all of you are able to see my screen. So you can see, are you able to see my screen? Hello?
Yeah.
Yeah. So here, these diagrams you can see, okay. This is how the setups will be there, okay. So Where is the ECU? Huh. Here you can see, right? This is the ECU. Sorry, let me take all these diagrams into. Let me take all these diagrams to notepad. You can see the diagrams now, right? All the diagrams. So this is how the connections will be there, but it looks like very clumsy, but then nothing will be there. Okay, this is it will have a lot of CAN communication. That's the reason you will be seeing a lot of CAN cases here. These are the CAN cases, we call them. So which will be used for the CAN communication in real time. In the project level, we will be having only one ECU, right? But the CAN in the real vehicle, so along with our ECU, there will be hundreds of ECUs, right? So these hundreds of ECUs will be replaced by these CAN cases. Okay, our ECU will think that it is sitting in the vehicle and it is communicating with all other ECUs if these CAN cases are connected. And this is a power supply which we might have seen in our BTech days, which will be setting for the 12 volts or the 16 volts or 8 volts power supplies and all those things. Okay, normal what we call them as the power supply only, right? Yeah, power supply only. Okay. You can say I wanted to show you the ECU. So here it is the ECU. Okay, this is the ECU. Okay, so the entire testing, whatever we will be doing it, right? They all are like simulations only. Where is that ECU? ECU, and this is the, you can consider this is a Latterbatch debugger. Actually, this is a WinIDEA debugger, but in the similar way it will be there. WinIDEA debugger. Similar way we will be having. We will also have the Latterbatch debugger. I will be telling what is the need of all of them. Okay. I will be telling what is the need of all of them. So now if you tell me one thing. So now we have the software readily available, which we need to just to flash into the software, right? This software we need to flash inside the ECU, right? Correct. So to flash this, we should have the one device, correct? So if this device is there, that device itself we calling it as a debugger or flashing tool. So in our case, the debugger is Latterbatch is what we are telling. Latterbatch. Okay. So and also this debugger not only for flashing. Okay. Will also be used for the debugging purpose. Why? This is the development project, right? This is the development project. Whatever the code you will be writing at a time, it will not work. It will not work. So what exactly it is happening in the microcontroller, what exactly it is happening in the ECU, all those things on real time we need to see it. So to see them, this with this Lauterbach debugger, we should also have the one user interface, right? Which is application. So we will be having the trace32 as a application, user interface application. Trace32 we call that as. So whatever it is happening on the ECU, whatever it is happening inside the ECU, with this trace32 you can see on the your laptop screen. Correct? This will happen in case of software, but the CAN communication also you wanted to see it, right? So for that we will be having the CAN case, we call it as hardware CAN case. With this CAN case, there will be one software application tool which we call it as a CANOE. With this CANOE tool, we will be able to see. We will be seeing the trace32 and CANOE, and we will also be flashing it. So now I wanted to tell how exactly it will be connected to your laptop. So this is your laptop, okay? Laptop. So inside it, you have the trace32 application, trace32, and also you have the CANOE application. Okay. Now here there is a ECU connected. This is the ECU. Okay, it is independent of your laptop. Now you wanted to flash the software, right? With this trace32 application you can flash inside the ECU, right? But this trace32 cannot understand what is this issue, how to flash and all those things. Okay, so that's the reason in between we will be having the debugger, which is a Lauterbach debugger. Lauterbach or WinIDEA debuggers. Okay, similar way. So the CANOE is there, the application. You can see what and all CAN messages are getting transmitted from this ECU and received to this ECU. But you cannot see by seeing the hardware, right? But you should have one simulation tool, which is a CANOE. Okay, so for this CANOE also we have the CAN case hardware, which we have seen just now. So this will be get connected. Correct? Getting it? With the USB ports, we will be connecting them. Guys are able to understand it? And then there will be
Yes.
a power supply. Power supply will be there. Power supply will be connected to ECU. Power supply will be connected to your debugger. And anyhow, the power supply will be there from ECU to the CAN case. And your laptop, anyhow, it will be having the power supply. Correct? So this is the setup what we were seeing here. You can see here. This will have a lot of wires and all, but don't worry about all those things. Okay, it is just it is having 4 CAN channels, so that's the reason it is having a lot of wires. This is a debugger what we are speaking. So this debugger, it will go and it will connect to your CPU here. Okay, and this CANOE also, where is the hardware? Hardware, it looks like they kept in down. Here you can see. So this debugger is connected to your ECU and other end will be connected to your CPU. Okay, similar way, CAN case one end will be connected to your CPU, one other end it is connecting to your ECU. You can see here. This is the power supply lines. Getting it? So this is what he will be seeing here. You can see this is a CANOE tool, but anyhow I will be showing that CANOE tool and all those things. But you can see here, whatever it is happening on this ECU, you can see on your PC. If CAN messages, if you want to see what and all messages are getting transmitted or received, then you can see on the CANOE tool. If you want to see how exactly the software is running, what and all parameters is getting updated and all, that also you can see on the you can see on the laptop with the Trace32 application. Getting it? Guys, any doubts here? This is the flashing, how we will be doing, what and all tools we will be using it in the real time, how they will be getting connected and all those things what I'm showing right now. Any doubts here? No doubts, right? Then I will be flashing into the software now. I will be flashing the software into ECU now. I'm resharing my other laptop. Just let me know if you are able to see it. You can see my screen?
Yeah.
Fine. Just now we are done with the build, right? The compilation. Okay, I think 10 minutes back we have done the compilation. You can see there will be hex file generated. Okay. You can see at 9:11 the hex file was generated, which because of our compilation only. Okay, this file I will be taking and flashing inside the this file I will be flashing inside the ECU. You can see here 911. So this is the file which I will be going to flash. Control C, Control V. Okay, now so you can see here we have the different tools. Okay, this is the trace 32. You don't worry about by seeing all these windows. Okay, it will be usually in this way. It will be in this way. Okay, so first I wanted to reset. There might be already software flashed, right? Which I don't want to happen. I want to erase that software and flash my new software. Okay, so now TC39X is the my controller which will allow this particular debugger. This trace 32 knows that which controller is connected, that we will be selecting it. Okay, so that also I will show. So inside this, if you go here from, if you are starting here, right, then it will ask now which controller is yours. Mine is 397 XP. Okay, so then it will ask whether you want to flash internally. So I wanted to flash. Which file I wanted to flash? This is the one 911 which it is generated, right? This file I wanted to flash. Now it is getting flashed. You can see down. You can see the update. Each and every memory location it's updating now. You might have remember like when we were discussing about the memory organization of any microcontroller, we studied about the code segment and all, right? So that part that entire memory location is getting updated with the hex file whichever we have flashed it now. So now flashing is done. You might have seen the comment executed. Okay, if you are not seen it again, also I can able to flash it. So here you can see now it will be a pre-flash check all okay, executing flash, reprogramming off. So the flashing is done. So now what I will be doing it, I will be just resetting it. Don't worry about this options. Okay, this is up to the debuggers what it will be using in that particular project. So it's up to them what under the options it will be there. Okay. So now in this particular debugger we need to do all these things. In target reset, in Aptiv they are having the different script behind it, so which will just ask you which file you wanted to flash it, but in our case we are not having any scripts and all. Manually we will be flashing them. So now you can see the down, it's the ECU is running. Okay, this is the trace 32. Behind this there will be Latterbach debugger connected in between this trace 32 tool and our ECU. So if you are flashing from here, that debugger will take care how to flash into the ECU. Got it right. Now I have flashed the latest software into the ECU. Now this is the Canoe tool. Okay, so initially it will not be having anything. Let me stop it first. This you might have seen already in your CAN and UDS classes also. Okay, so here now it's not running. This Canoe tool will be connected to your ECU with the CAN case hardware. Getting it, guys? Any doubts here? Fine. So if I'm running this particular CAN case, so now it will show what and all messages are getting transmitted and received by the ECU and transmitted from the ECU or something like that. So here you can see these all are the CAN messages it is getting transmitted by the ECU. So here to the RX to the Canoe. RX means receiver by the Canoe. Then who is sending? No one else is there in the communication. Only our ECU is there. So that ECU itself it is transmitting all these messages. Getting it? So you can see what and all information it, what that CAN data is holding is this kind of information. Getting it?
Yeah.
So these are the CAN messages which our ECU is transmitting, which is received by the CANOE tool, which we are expecting to transmit for every 1 millisecond time. In such a way that what we have done in the coding is that these all messages should be transmitted from our ECU immediately once after we are starting the ECU for every 1 millisecond or 1 second. So that particular information, that all messages should be holding this information. You can see the data also. You can see the data here. Direction you can see here. What is the DLC length? What is the data length? What is the data it is holding? All those things. Okay. Now this is the one case. Okay. Now other case. So if you wanted to transmit any data to your ECU, then how can you transmit it? Any idea to anyone? For that, we will be creating the IG block actually. So you can see here, interactive generator, can IG. We are already having it, so that's the reason I don't need to do it anything. So you can see here if I'm transmitting, see for example, our ECU might be needed to have the any, what is that? Our ECU might be wanted to have what CCVD1 will be having it. Why it's not going? Yeah. This is not having the proper data. It's having it CCV1. What is this? So this CCV1 and EEC1 will be basically the CAN message basically to know what is the engine speed in RPM. How much speed the engine is running is what it will be telling actually, but it is not giving any of its signals actually. I don't know what is the reason, but I think the DBC files will be there that we have not attached properly. It looks like maybe that's the reason. CCVS1 is for the how much speed your vehicle is going now. Okay, similar way we are having one more message here. You can see here. If I am transmitting this message, okay, so it will be transmitted by the you can see here. This is the TX message, okay, 18EF4127S. This is a proper message which we are transmitting 01. You can see here in the 0th byte 01 we are transmitting. You know, right? The CAN communication will have only 8 bytes of data. Each message will be having 8 bytes of data. So in that 8 bits, 0th byte I am sending the 01. So here also in the CAN trace window also you can see 01 is getting transmitted periodically. Okay, so this is getting transmitted. Will be received by the our ECU. That also you can see. CAN1 will be receiving that. So if you want to transmit any of the data from your CAN case, then you need to create the IG block. If your if your ECU itself, if it is transmitting any of the data, that you can see in the trace. The trace where it will be there in the analysis in the trace. Here you can see the trace. Got it? Whatever the messages it's getting transmitted by the ECU, all those things you can see here. The TX in the sense from CAN case you are transmitting, from CANOE you are transmitting it to your ECU. Any doubts here? If no doubts, I think then we'll see the diagnostics part now. This is how the CAN communication will be happening. Okay. Now we'll see the diagnostics. So you might have seen the 10 service, right? So for these diagnostics to directly, just click on 10.01, 10.02, 10.03 and all. What we will be doing, in the diagnostics IS4TP, there will be one CDD file, okay, that we will be attaching it. This CDD, whoever the diagnostic developer is there, right? That guy will be doing the CDD integration and all those things. So that CDD will be, I will show you how the CDD looks like. So here you can see, this is the CDD file, okay, which will be developed by the Candela Studio. So either it may come from the OEM itself, or it may be developed by the tier 1 supplier itself. Okay, you can see all the DIDs and all we will be configuring here. Sorry, variants. So the sessions means what? 10th service, UDS 10 service. Default session programming and extended session is what we are supporting. And ECU reset is what? 1101 we are supporting. And security access is what? 27 1 2 3 4 we are supporting. ECU identification. Here we will be having all the read DIDs, write DIDs and all those things. 22 and 2E services, it will be here. You can see here only read service it is supporting, which is requested will be in the 22F131 format, and a positive response if it is, then 62F131. Negative response 7F22 whatever the NRC. So all those DIDs and all we have configured. This CDD file we have attached into the Canary tool. You can see here. So that's the reason if you are opening the Canary, diagnostic console window, which you can open from here. This window will come. Why? Because in the similar format, however we have seen in the CDD drive, same format it is coming here. All these tools are from the vector itself. Okay, that's the reason this compatibility will be there. So I'm running now. So can anyone tell me if I am giving the 10.01 service, if there is a positive response, what should be the response ID? If I'm giving the 10.01, if it is a positive response, then what should be the response from ECU?
50.
50?
01.
Correct. So if I'm sending 10.01 from the tester tool now here is a Canary and your issue is the server. So if you are requesting 10.01 to the your testing tool, so your not testing tool, sorry, to your issue, then issue has to respond it. So this is how the exact diagnostics will happen in the service centers also. They will be connecting one diagnostic testing tool, then they will be running all these testings. Then they will get to know what is the issue. Okay, now I am just running 10.01. You can see 10.01 it is getting the positive response in our can diagnostic console. You can see, and if I am filtering here only for that message IDs 18DA F9 F941, you can see here. So what is the TX we have done? Let me minimize all these things to make into this single frame. Differentiation I don't want. DLC direction is fine. DLC is this one. Data is this one. Okay. Now I'm sending 10.01. You can see here. Why only one message is getting filtered now. I wanted to filter 18DA41 F9, 18DA F9 41. And now if I give, so you can see TX you are doing it, which is a 2 bytes of length, and 1001 you are sending it. You can see the green one here, okay. So what it is getting? 5001. Getting it? So 50 is the positive response, 01 is the sub function, and P2 and P2 star timing parameters also it's getting. P2 value is a 50 milliseconds, P2 star is a 500 milliseconds, which is a 5 seconds. This P2 and P2 star you might have studied in the UDS class. Okay, similar way, if I'm giving 1003, so you can see 5003 you are getting it. Then if what the DID we have seen it, FD41, right? Application identification number. So either you can run it from here also, 22 FD41. If I'm doing also, I will get it. So 22 2801 is the one which we have seen it, right? You can see here also the positive response. 62 FD41 22 2801. So 22 is the year, 28 is the week, 01 is the patch number. Got it? Similar way, if you want to see like what is the repair shop code or test serial number, I am not sure whether it is implemented or not. So repair shop code also we will be giving test serial number. So which a particular testing tool is going to connect with this ECU also we will be keeping it. So as of now we have given all 20 20 20s. In ASCII value 20 means it is a space. Okay. So and also you can see vehicle manufacturer ECU hardware number also we have given. So vehicle manufacturer has given this is the ECU hardware number Q21 1165 001 002 or like that. You can see here also DID F191 raw data also you can see here Q21 1165 001 002. Getting it? So this information where it is there? It is there in the ECU. If tomorrow if something is happened, so if you are going back to the service center, if you are asking that, then he will know, he will get to know that all your vehicle details. It will be there already in the cloud storage. Then if he is reading and it will just compare that. So now they cannot able to change the spare part and all also. That's the advantage if you are going for the servicing to the any of the your authorized service centers. For each and every part number, there will be a serial number. Getting it? This is how the UDS we will be doing it. This is particularly for the 2E service, 22 service, 2E 19 and all those things also. This is the routine control, which is 31 control, 31 service, and 3E is the tester present. If you want to keep on engage this testing tool with your issue, then you will be sending this symbol tester present, or else you can run the 3E00 also fine. Tester present activated. It will be keep on sending to your ECU so that your ECU knows that tester tool is still it is connected with me only. Getting it? Any doubts still here? So this is the Canary tool. Okay. I hope all of you are able to understand this. Any doubts here? If no doubts, I think then we'll see the. Let me stop it. So if I'm not providing the power supply, okay, I have the controlling to switch off the power supply also. Relays we have connected it. If I'm doing the relay power supply off, then you can see here power down. So which means that for ECU will not be having the power supply. You can see now there is no power supply to the ECU. Got it? So that is how we will be doing these testings and all. Then This is one similar kind of tool for the code check-in and check-all. So before that, I wanted to explain the little bit other things. But I will not be showing this tool. I will be showing the plastics which you could able to understand easily. Okay. So almost all tools we have seen so far. Guys, if you want to explore more things into the either Rhapsody or EA tool, yes, just go through the YouTube videos at least once. Okay. If you are not able to understand, if I find any of the videos also that I could able to give you, no problem for me. Okay.
Yeah, you said to remind about quality tools.
Quality tool, correct. Thanks.
Yeah.
So basically, quality tools is what you know. So I think we might have studied it already, but let me revise once again. Okay. So quality tools, quality check. Okay. So this quality check. So for writing the C coding, we have the C99 coding guidelines. Okay. So this coding guidelines, I remember we have seen once the QSC document also, QSC 2012. You can directly Google it and you will get it, the document. If not, immediately I will also download and I will share you. That is important. Okay. 2012. I think I have it. Let me share it here. Immediately I will share here. C coding guidelines. So whoever doing the coding, right? So they should follow all these coding guidelines actually. Can I share? Just see if there is any message. Looks like it's not allowing. But you can search it here. There is a one website, okay, which it will show you. Video 2012 PDF. I don't know. I have research gate only. Yeah. Somewhere it will be there. This one only. This one only. Yeah. So this document only, okay, this will be saying how the C coding has to be implemented, okay. I will share this document immediately after this class, okay. Thanks, so we got that, okay. That will be saying how the C language should be implemented, okay. So there will be tools, Misra coding guidelines check tools, which are like PRQA and other tools which are like Polyspace. Similar kind of tools will be there. So this, whatever the software we will be writing, right, we will be uploading that software into those tools. That tool I'm not having. There is a separate team for that again for us. Okay, so if we are uploading into that tool, it will says that what and all rules we are not following particularly. So if it is saying that rule 7, use suffix shall be applied to all integer constants that are represented as an unsigned type. You guys are not able to see my screen, I think so. Not sharing that screen. Huh? Fine, I will be sharing here only. So here itself you can see. So here you can see, okay, all the rules will be there in this document. Misra coding guidelines, we call them. For C language only, particularly, they will be having these coding guidelines. You can just, after this class, I will be uploading this document. You can just go through once, okay? .2 Control F 7.2. So rule 7.2. So a u or caps u suffix shall be applied to all integer constants that are represented in an unsigned type. Okay, if you are doing anywhere the unsigned type, you can see in my coding itself. If I are doing anywhere the unsigned type, you can see particularly here, I might be doing appending with the U. See, this is unsigned value, but still I am appending with the U to indicate to the compiler that this is unsigned value, either small u or caps U, capital letter U. This is one of the coding guidelines. If I am not following this rule, for this particular line, it will throw an error, which is a QSU warning. So let me show the QSU warning which we received from other teams. Guys, you are able to see my screen, right?
Yeah.
So where we are having, where is this documents? RBD, PWC documents, test reports. So Polyspace is the one which we are running. Okay, Polyspace, inside this you can see this kind of Excel sheet it will generate. Okay, a Polyspace I don't want here. Bahus you can see. Bahus also one of the tool again. So in this Excel sheet it will throw on. It will generate all the warnings. Okay, so you can see unsigned, unused macro declaration, all these unused parameters in the so and so file. So if I wanted to see in my, so if you see my file which we were seeing it, right, diagnostics file, it is having a lot of errors, so a lot of warnings, so that's the reason this much slow. So only that file I am going to filter it. Okay, so unused parameter, what it is saying, so at the line number whatever it will be, so unused parameter, and also it will say what is the rule. Misra C 2012 2.7 rule, it is saying that there should not be any unused parameters in the code. Okay, similar way, u suffix constant of unsigned type, we saw it, right, 7.2 rule. So it is expecting u or the suffix. Okay, what is that? So it was there previously, but I corrected it. So whatever we saw it, right, 800000 and all. So here it was expecting U. Previously there was a warning, then I fixed it by keeping the U there. Okay, so that if you are not following any of the rule, okay, then it will throw an error, throw an warning actually. Got it? This is what I was wanted to tell you guys. This is the quality check tool which we will be using it. Okay, now I am sharing here once again. So we have seen ALM tool, similar kind of thing, and the enterprise architect, which is a kind of Rhapsody. Notepad, anyhow, you guys know it. Vectorcast, I will be sharing the video. Jira, we have seen it just for ticket tracking. Trace 32 and Canoe, you have seen it. But what we have missed is the configuration management tool, plastics. Correct? So can anyone tell me what is this configuration management tool? Guys, can anyone tell me what is this configuration management tool? Any idea? Can anyone knows the GitHub?
The configuration in the sense like in general, it is like uh, settings. Settings.
No, in the not that one. The configuration which we were speaking, the DaVinci configuration and all, that is different. DaVinci configurations and all. This is fan madam. Fan. Fan. ఇది కాదు అది. So that configuration is a different thing, okay? So GitHub and all, you can see like, so code check-ins, checkout and all we will be doing. Code check-in, checkout. These are the terms we will be hearing in this GitHub and plastics and all those things. So what will happen? Why it is needed, you know? So there will be 10 developers, okay? Sorry. So there will be 10 developers who will be working parallelly. So you saw it, right? I will be doing the diagnostics. Someone else will be doing the TSR feature definition implementation. Someone else will be doing the AEB implementation. But all these things might be going for the release 3 only, R3, which is a software release 3. Okay. But so if you are working parallelly, it shouldn't affect that to merge all those code. Okay. Correct. So for that reason itself, we are coming with the SCM, software code, software configuration management or something. Code configuration management. Some people will call CCM, code configuration management. Source code change management, code change management. Some definition is there, okay. But this is the concept behind that, okay. So what will happen? Whatever the tool which I will be going to show you now is the plastics. So this tool I never seen any of other companies are using. Only Aptiv is using as of now. Okay. So what will happen? This plastics. So if 10 members, not 10 members, if 100 members are working also, we will have the some branching mechanism. Okay. Let me take the fresh page. We will have the some branching mechanism. So there will be one branch. Okay. So there will be already one base change set, we call it a base change set, which will be having the software as of now. We have done the R2 software, correct? R2 software release we have done. That software is there in this particular bubble. Now I am going to take the branch from here, which I will create here my home branch. my home branch for Lokesh. Here I will be doing my entire R3 software development. So the software which I wanted to release for R3, I will be doing development here. Now here Pritham came. Pritham created one more branch. He will be doing the TSR future development. For all his code changes, he will be doing in this particular bubble, R3 software. Now Satya is there. Satya also took one more branch, which he is going to create his own branch. This is for the AEB future, which he is going to develop for the R3 software. We three are developing parallelly. Okay. Then again, these three softwares, whoever doing the parallel things, right? This should be merged and will be releasing the combined software to the customer, right? So what I will do, I will go and I will merge this software into this branch again. So it will come here. It will create one more branch here. Okay. Now after me, what Satya will do, Satya will he might have finished his development, AEB future development, and he will merge into the main branch. So what it will happen here, again one more branch will be created. So this branch this branch will be containing the base changes along with my changes and Satya changes also. Now what Pritham will do, Pritham will create one more branch. Pritham will merge once again. So what it will be happening here, one more bubble will be created. Now this bubble, what it will have, base changes plus Lokesh changes plus Satya changes plus Pritham changes. So this will have the all the merged changes. So Pritham no need to combine my changes or Satya changes again to his, or you can just do combining. He will just merge into the main branch. This we call it as a main development branch. Development branch. These are the who? These are the individual branches. Individual developer is creating branches. If we want to continue in this branch itself, we can create one more bubble. Then this bubble also you can merge into here. If there is any bugs, then he will take these changes to here. He will do the changes. He will create one more branch again. He will merge it. Getting it, this concept? So this is in the app too, okay. The similar tool will not be there anywhere, but this tool will be getting changed to company. But you should know the concept, okay. This check-in and check-out and all these terms, they will be using it. Check-in in the sense, so here my changes are there. This I am going on to check in here. And here Satya changes are there. Satya is going to check in here. Here Pritham changes are there. Pritham is going to check in some other bubble, something like that. Check in the sense the code changes, your local changes, whatever it is there in your local PC, it will be going to check in into the servers. Getting it? If you are creating branch from your base bubble to your local PC, that means that in your local PC, one more entire software, whatever there in this branch, it will be get created locally in your PC. Getting it?
Yes.
So this is how the code configuration management will happen it. Got it? But now I will be showing that real-time plastic tool. You guys are able to see my screen, which I'm showing the plastic tools actually.
Yeah.
Yes.
So this is the plastic tool, okay? Plastic SCM. Okay. Similar way, whatever we have discussed it, right? Now you can see there will be a integration branch or development branch. You can see similar way. Someone took the child branch here. Someone also took the child branch here. Then he has done his changes and then he checked in into here. So from here to here, the changes it came here and there is one more bubble created. Got it? So similar way, from there again, a couple of people got their branches and they checked in. They are doing their manual changes. Okay. So in this particular check-in, so here you can see if you want to create child branch from here, so you can click on this and create branch from this chain set. Okay, switch workspace to this chain set in the sense already. So here there is a home branch, right? What does that mean? So whatever the code it is here, right? It will be there in your local PC also. In local PC where it will be there, it is here. Here, this folder structure and whatever you are seeing in the plastic, right? It should be same. If it is showing the home here means it is showing home because this particular chain set already it is there in your PC. If I am doing any changes here, then if you want to see what and all changes if you are done, then you can go ahead and you can see the pending changes. Pending changes, it you will show that what and all changes you have done locally in your PC, which is not there in the server. So if you are double click on this one, right? So you can see this is the change you have done it. So previously, this only this if part was there. Now you changed it to the local changes. All these changes you have done now. Got it? So if you want to check in all these whatever modified changes are there, right? You can just right click on this, or else you can do here the check-in. It will not allow. You should give any of the comment. Okay. If you are clicking this check-in, okay, then it will go and it will create one more branch here. One more branch here. Here it will create. After this bubble, immediately one more branch it will be get created. If these changes you want to merge into this main branch, right? Then what you need to do? Right click on this, merge from this chain set. So if you are doing merge from this chain set, so then again it will create one more loop to here. One more bubble somewhere it will create here. Getting it? And also you can see the dates here. 7/12/2022 is the one who created this chain set here. So this is how the code configuration management we will be doing it. Any doubts here?
No.
Fine. Then I think for today, that's all what I'm having it. And I hope most of the things we are done already. This tool parts was the one which was pending actually. I think with this we are done actually almost all the things actually. So only the pending thing is vector cast, and I need to provide if there is any enterprise architect video. Enterprise architect, I hope you could able to get in the YouTube also. If not able to get, then let me know. We can have the one special class for that if anyone needed it. And vector cast, definitely after this class I will be providing this video. There will be 1.5 hour video. I may post it in the Skype itself. And QSC document is one which I need to let me write it down. Bannni much. So QSC document and vector cast video is these two things will which I will be going to send it immediately. And ADAS project, ADAS understanding document, understanding project understanding document. Okay, these things I will be going to share here immediately after this class. Any other doubts? If no doubts, I think we are good to go ahead and we can we are ended up with all the sessions. There is no major classes and only for AutoSAR. If anyone is entered into the AutoSAR project, they can request for the special class to the Pawan so that we can have the special class schedule for it. But apart from this schedule, whatever we have planned, almost all are done. Thank you all. I think it was very nice interaction with all of you. Thanks a lot.
Thank you.
Bye
Thank
bye.
you. Bye.